Good morning, class. Today we'll be discussing linear regression. Now, for a linear regression, you'll need two continuous quantitative variables for your M&Ms. Now, one of our quantitative variables was weights, because it's continuous and quantitative. Our second continuous quantitative variable was the diameter, the length of the diameter of the crushed M&Ms when it is squished between two books. So if you look here, we have a graph, a bar graph of these continuous variables. So as you can see, when the diameter of the crushed M&M is plotted against the weights, it results in a nice looking linear regression here with a bunch of blue dots and a red line. With an r-squared value, this trend line has of 0.173.
And his name is John C.
For chapters 2 and 6, data was collected by numbering and weighing each M&M and counting out how many M&Ms of each color there are. For chapter 6, we had to create a Venn diagram. A Venn diagram shows the relationships between two sets of data or multiple sets of data in the format of circles. So this Venn diagram shows the probability of an M&M being blue, weighing more than 2.2 grams, both, and neither. Moving on to chapter 2, we learned about Chebyshev's inequality. Chebyshev's inequality shows how much of the data falls between a given number of standard deviations. The equation is represented by 100 times 1 minus 1 over k squared. For one standard deviation, it's very trivial because at least 0% of our data will have to fall within that standard deviation. Moving on to two standard deviations, we put 2 into k and find that at least 75% of our data should fall within the second standard deviation. We then take the mean of our data and add and subtract the standard deviation and count how many points of data fall within that range. And at least 75% of that data should fall within that range in order to apply Chebyshev's inequality.
In the whole bag of M&Ms, and so there were 14 blues out of 40, which is 35%. And I decided to see how long it would take for me to pick my first blue, calculate all the odds, and this is what I got. And it's a geometric distribution because it's independent. There's a fixed number of successes because I stopped with the first blue. There's a success or failure. Blue is a success, failure is not a blue. And every selection has the same chance because I would put the M&M back if I didn't pick it. So there's a 0.35 chance. And basically I found this formula, 0.35 times 0.65 to the x minus 1. If you wanted to find the x value and the probability that you have for that x value. So let's say you wanted to see what are the probabilities that the first blue you picked were on 2. So you just plug in 2 and then you get your answer. And this is the table. And the really cool graph you can see as x increases, y decreases, but the rate of decrease also increases as x increases. So it's growing exponentially lower.
점잖아 보이지만 놀 땐 노는 선어해 내가 되면 완전 미쳐버리는 선어해 근육보다 사상이 울퉁불퉁한 선어해 그런